Hello, math magicians. On this lovely day, we are going to be examining distributions as a whole using something called box plots. So let's refresh ourselves about what box plots are. First off, they are also commonly called box and whisker plots, for the reason that they have boxes and a whisker. And ultimately, these show the distribution of data. And we'll unpack that in just a minute. Let's take a gander at some things and look at some data here. So first off, this is some data on an algebra test here. So this is not in order necessarily of the tests, but this has been ordered by the score of the test. So 61, 61, 65, all the way up to a 94. So let's define what first what a few things are here. So number one, and sorry about this right here, I'll move it in your handout. It should be down below. Quartiles. Quartiles tell me about where the quarter, or 1/4 of the data lives. So 1/4 of the data. So a couple things that we have are important is the minimum, and that's my first number that I'm dealing with. So this is called my minimum. And of course we also have a maximum, and that's at the tail end. Then we have what are called the next one is easiest to consider as the median. So that one here is my median. That's my middle number. Now, the other two, the first quartile and the second quartile, also known as Q1 and Q3, this is the middle of this half of data. So just from the minimum to the middle, what's the middle there? And from the middle to the maximum, what's the middle of that? So Q1, Q2, Q3. So I'm going to abbreviate that real quick. This one's Q1. This one's also called Q2, and lastly Q3. Altogether, these are called the 5-number summary. And let me spell that correct. Summary. Okay. Of a distribution. One important feature of this is called the IQR. And IQR means the interquartile range. And a range is a single number. It is a single number. So it's defined as this: whatever Q3 is, whatever number that is, minus from Q1. And let's just show you on a box and whisker plot what that might entail. So here's Q3, here's Q1, so it's just how long this box is. Why is that important? Well, the IQR tells me where 50% of the data is. 50% of my data is hanging out in this box. Other ways of interpreting and paying attention here is, here's 25% of my data, 25% of my data, 25% of my data is tightly squashed into there, 25% of my data there, and 25% of my data there. So that helps us to actually see the spread of things. Are things tightly packed? Do I have most of my data, so 75% of it, in just a small little section, and then the rest of the data is way out? So this helps us just to see where things fall in terms of how many of each are there. So this right here gives you an opportunity to show you how to find the 5-number summary using the TI-84, so go to that to check that out. So in this example, in 1998, the American Film Institute unveiled a list of the 100 best American movies of all time, as judged by 1,500 members. Here are the top 25 with their years released. So Citizen Kane being the top, 1941, and being the 25th down there is Extraterrestrial, 1982. So once you enter all this into L1, you can go to the stats and STAT-CALC, and then choose the one variable statistics. So I'll do that real quick and then write stuff down. So after I enter all that data in to L1, I can go STAT-CALC one variable, and here's my min, 1938. My Q1 is 1944. Q2 is 1957. Q3 is 1973. And lastly, my max is 1993. So how do I make a box plot from here? Well, first thing I'm going to need is a scale. So a number line here, and notice where I'm going to go. I have to be all the way, the lowest at least has to be there, and my max here has to be there. So I'm going to go down to 1935, to this one, 1935, and go all the way up to 1995. Now from here, I have to try to make my separation here, my units, work out evenly so that 1995 matches up well. So I have my scale here, and I abbreviated and dropped the 19. All right, so what to do next? Well, I just have to plot these 5 numbers. That's it. Plot these 5 numbers and get them as closely as possible. So 1939 is right under 1940. The next one is 1944, which is right under the 45. Next is 57, so somewhere approximately there. 73, about here. And lastly, 93, about here. Now all we have to do is make our whisker, make our box, like so, and make our other whisker. And that's the whole thing. Now what's nice about this is it tells us where the data is. 25% of the data falls just in this small little span right here of 5 years. So that's a quarter of the data. And the other quarter of the data is way over here in this 20-year gap. So in this 20-year gap, 50% of the data is. So as you see, a lot of fine films, it seems, in this small gap right here, and then stretched out there. So that's how we make it. Now, it turns out we can also do this on the TI. You just have to select a different plot. By way of practice, go ahead and enter this into your L1 or L2, and then you can find the 5-number summary. Then draw a box plot. Now to check your work, here we have our min is 24. Q1 is also 24. Our Q2, also known as our median, is 34. Q3 is 83.5. And notice that our max is going to be 200. Down here is a picture of what the TI-84 can do for you. And just to give you some perspective, where the min and the max, etc. are. So clearly this is 24, so that's my Q1, my minimum and my Q1. And then of course the next one here, this one is 34. This one here is 83.5, and this one way out here is the max at 200. So of course the first thing that we notice is maybe we've got one hanging out here, so that's a problem. Okay, so that, in fact, the lonely one out here does in fact have a name. It is called an outlier. However, our instinct or our first thought is that it is an outlier because it's so far away from all the other data. But we want to be mathematically technical when we approach this. So before we can determine if it is an outlier, we need to define outlier using the numbers we have. So here's a mathematical formula. Effectively, what we're going to do is find out how large the box is, how large the IQR is, multiply that by 1.5, and we're going to see if there are any numbers that lie outside of that. So let me just diagram that just a little bit, okay? So here is the IQR. It's going to be the difference between these two, right? That's how wide it is. So there's my IQR. Now, if I were to take exactly that and shift it over to here, we now have the IQR there. But what we're going to do is stretch that out just a little bit by 50%, so we get this much here. So this here, this whole region right there, is IQR times 1.5. So anything that lies outside of this, anything that lies outside of that is going to be an outlier. So there could be 2 or 3 numbers that are out there. Well, it turns out not only are we going to have an outlier potentially above, but we could repeat that process over here. I could take 1.5 IQR back here and see if there are any numbers that fit there. So just to see what that might look like, so here's 1.5 times the IQR. So any numbers that are hanging out in this region. Now clearly there are no numbers because the minimum in this data is right here. The maximum of this data here, so it is outside of this, what we might call normal. So because of that, 200 is the only number that falls outside of that, at least in this. So, but let's show the calculation actually. So we know how to find IQR. IQR is just Q3 minus Q1. Okay, so that is 83.5 minus the 24. We're going to multiply that by 1.5, see what we get. So we get 89.25. Now what we're going to do is add that to the Q3 here. Here's my Q3, so we just want to see how far past Q3 it goes. So Q3 is 83.5. So when we add that together, we get 172.75. So anything that's past 172.75 is an outlier. So the answer now is that 200 is an outlier. Learn to spell. And there we go. So now I want you to take a moment here. You're going to plug these numbers into your calculator, L1, L2, L3. Find the 5-number summary. Draw a box and whisker plot just right here. And take a moment to see if there are any outliers here. So go ahead and pause the video and then come back to check. So here's my 5-number summary. Here's my scale, and let me just go ahead and plot the 5 points. 46, right about there. 53.5, right about there. 63.5, right about there. 73.5, right about there. 81 here. Now make the whisker. Make a single box that goes around Q1, 2, and 3. And then connect the dots there. And in terms of outliers, my instinct says no, there are no outliers. Because look, even this width right here, clearly, if we were just to see how wide IQR is here and repeat that over here, I don't see anything that's going out this far. So just to demonstrate that real quick, the IQR is 73.5 minus 53.5, so it's a gap of 20. If I multiply that, 1.5 times 20, that's going to give me 30. And clearly, Q3 plus 30, so Q3 is 73.5 plus 30 is equal to 103.5, which is greater than 81, which is my max. So there are no outliers. So that's my conclusion for that. And this would just be some backup work. But clearly we can see that just by eyeballing it. There are no outliers here. The last thing we're going to do here is match the histogram with the box plot, and we're going to explain reasoning. So I'll walk through one of them. You finish the other two. Make sure that on your notes you're also going to spend some time with some questions on the side and write a brief summary. So let's see this first one here. Here we have one little thing that's hanging out here, one little thing hanging out here. So these two are combined. Notice that Most of the data is compact right there. So here is most of my data compact right there. So because of that, because of the skewed to the left, and if I had to say at least 75% of my data is clustered, and with some outliers. So those are my reasoning right there. So take a moment and work through the other two. Which one of these are they? Finish some questions, summary. All right, have a good one.